Welcome to Lecture 6.2, ROS Packages. ROS code is arranged into packages. Before we can describe packages, though, we need two apparatus, the ROS build system catkin and the ROS workspace. Okay, so we'll introduce those now. The ROS build system catkin. Most software is written by programmers as source code in some programming language. Okay. In this text, we write source code in Python. When the software is ready to be used, it is converted from source code into binary machine code and packaged up for distribution. A piece of software that controls this process is called a build automation utility. Examples include make, QBS, and Cabal. ROS has its own build system, catkin, built atop CMake, which is itself built on top of make. It shares a name with the cluster of flowers, such as that of the willow pictured in figure 6.3. So this is actually a catkin, the catkin of a willow, male catkin, according to Wikipedia. Because we are developing in Python, we will use only a few of catkin's features, some of which are introduced in the following sections. So think of this build automation utility as something that's going to sort of package up, distribute, or package up for distribution our catkin packages, okay, and get them all set up for us so that we're ready to write our code. When we write it in ROSPy in the Python environment, we end up not having to do a lot with catkin. We just need to use a few of its features. So there's a lot under there. So if you pull back the curtain on this, there's a lot back there. Don't get too scared if you pull back the curtain and are blown away by the complexity. We will only need to use a small fraction of that complexity for our purposes. Okay, 6.2.2, ROS Workspaces. Workspaces are directories in which you can develop ROS code. Okay, that's what we're going to want to do, right? Develop ROS code. Each project should have its own workspace, and workspaces cannot interact. So if you're working on some part of your project that is related to another part of the project, but is not maybe directly working on that other part, it's fine. Just keep it in the same workspace, okay? Don't start a new workspace for something inside the same project. So within a project, stick to a single workspace. Setting up a workspace. We will now set up a workspace. Open a bash terminal. Okay, so let's do that in our virtual machine. We have the one that was opened up from before. We can reset and clear it so it doesn't freak us out. Okay, so we'll open up a terminal and we'll change directory to the convenient directory like your user home directory. So that tilde is what you can use to change to your user home directory. Make a new directory for your code like code as follows. So we'll cd to our home. So cd to home, and I was already there. If you want to know where you are, pwd will tell you I'm in home Piconi. That's me, that's my home directory. I can list the files there with ls. I actually already created a code directory here, so I will make a new one for the purposes of this lecture. Make dir code E, okay? All right, so that's what we did here. P creates the directory only if it doesn't exist, so I could have typed that in and it wouldn't have created a new code directory, but now if I do ls, I have a code directory. So if I then take this, take us down to the code directory, I'll cd to code. Now I'm in home Piconi code. Okay, I'll list the files in there. There are none. All right. Now we're going to make a directory ROS Workspace 01 for your new workspace. Could be named anything you like. Since this is a general code directory in my home directory, for my own sanity, I will call it ROS underscore something. So ROS underscore workspace 01 is what I called it in the text. So we are going to make the directory. If it's already there, it won't make it if we use this P flag. And we'll call it ROS Workspace 1. Okay, so now if I ls, it's there. So I'll cd down into it. Every workspace needs a source directory with the name src. So we'll make the source directory and we'll cd down into it. Since there are no files in here already, I don't need the P flag. Mcdir src, cd src, and of course it's an empty directory. Okay, so let's look at the tree that we've made with pwd. Home Piconi code ROS Workspace 1 source. Great. Now, initializing the workspace. Now that we're in the source directory, we can initialize a workspace, and we're actually going to use a catkin command here called catkin init workspace. So we have to call this from inside the workspace. Catkin init workspace. And I use tab completion there, and I highly recommend that you use tab completion when you're typing these commands in. There we go. And what this did was it copied a file to this directory called cmakelists.txt. So if we ls, we'll be able to see that showed up there, cmakelists.txt. Now we can finalize our new workspace using the catkin make command from the workspace root. So we have to go up to the workspace root, which means the top of the workspace directory. So we can go up a level by doing cd ... which will take us from the src directory just up to the ROS Workspace 01. So if you want to check where we are, it's home Piconi code ROS Workspace 1. Okay. And then we can finalize this new workspace by using catkin make at this top level. So catkin make does lots of things, and now we've made a workspace. So we'll investigate what we've done here now. So let's investigate the new directories in the workspace. We'll ls, see what's there. So we made this source directory manually. The build and devel directories are new. So we could cd into build, and we could ls, and it's got a bunch of stuff in there. We could go back up, we could cd into devel, and see there's a bunch of stuff in there. So this is what our cmake build did. Yes, catkin make, I should say. And so these are new. We will not make much use of the build directory, but the latter, the devel directory, will include the setup.bash file, which we will source in order to make available our new our shell the new workspace. So remember, when you open up a new terminal, you have a in your bash rc, if you follow those instructions, which I highly recommend you do, you source the general ROS installation setup.bash file. That happens automatically for every new terminal that you open. Now, if we want to work in a specific workspace, we have to then source our setup in that workspace's devel directory setup.bash. So whenever a new terminal is open and we're working in a workspace, we have to go ahead and type this in, source this workspace. You can add this if you'd like to your bash RC as well. You can source a specific workspace. That's great if you're only going to be working in one workspace, but if you have multiple workspaces going, that's not what you want to do. So we'll do that. We're in devel, so I was writing that command as if I was in just the workspace root. So I'm higher than devel, so I want to source devel slash setup.bash. Okay, that makes the current workspace, the ROS Workspace 1, available to our shell terminal. So everything else we don't have to do every time we want to work in the workspace. Now every time we want to work in the workspace, we do have to do the source. If you were already down in the devel like we were, so cd to devel, you could have sourced it by just doing source setup.bash. Would have been fine too. I had to do devel slash because we were in the root of the workspace. Great. ROS Packages. ROS Packages are code directories containing certain files and organized in a certain way. Packages are usually written for specific applications, but could be applied to many others. The ROS community tends to share packages and develop them cooperatively, but there are privately held packages as well. The ROS license permits this, so you can have proprietary packages for your company or organization. So first we'll learn to create a new package. Packages are developed in a workspace's source directory. Let's cd to that workspace created in the preceding section. So we're already close. Let's go up to the root of the workspace. We need to cd into the source directory. So that's where we are. Okay. We can create a new package as follows. Cat can create package, the name of the package, and then any dependent packages. So the dependent packages come afterwards in a list. You can keep going. So space, another package, space, another package. So cat can create package, okay, and the name of it. So we'll name ours sweet package. Actually, I already made one of those, so I'll do a sweeter package. And then I will include as a dependent packet, as a dependency, ROSPy. This means that sweeter package depends on ROSPy, okay? And it turns out that ROSPy is the package we'll include in every Python ROS package. So if you're going to write your package in Python, you need to have ROSPy as a dependency for your package. Okay. Let's created a directory, sweet package, and populated it with these files. So let's cd down there. See what's there. CMake lists, package.xml, and the source directory. So there's a new source directory. So you have your workspace source directory, and then you have your package source directory. Okay, so good to keep those straight. The first of these has information for catkin, so CMake lists.txt, and the directory source is initially empty. It will contain the package source code we will write. The package.xml file contains package metadata and should be edited. So if you want to look at what's in it, you can do cat. The cat command will print out the contents of a file, of a text file, to the shell. So we'll cat package.xml, and it will print out this not too long, but somewhat long XML file. XML files are like HTML files. They have tags like HTML files. They have comments like HTML files. Their syntax is very similar, but they usually contain data instead of web page information. So web page source. So we have the name of our package, the version of our package, the description of our package, and then a bunch of information about like the maintainer of the package, the license, URL to a website for the package, author tags, dependency tags, which are very important, etc. And that's, oh, I forgot an A in my name for Sweeter package, which is probably something that I should have been more careful about. So I printed out an abbreviated version of this in the text, and I edited it a little bit. I added my email address and name. I added a BSD license. If you're interested in the licensing, I would take a look at them. There are more restrictive, less restrictive ones, and there are nice interpretations of like what's the difference between them online. You can check all that out. Sort of most importantly are or maybe not most importantly, one of the more important tags here are the build dependency. So the build and execution dependency. So we'll talk more about the difference between these different depend tags, but notice that we put ROSPy into that command that created the package, and ROSPy gets populated here as in the depend tags. So later on, after we've done that initial creation of our package and we want to add other dependencies, so say we started developing, we wanted to add like the TF2 ROS package, which is a common package to use, then we'll include it here in the XML. Maybe we forgot that we would need it when we initialized this. That's okay. The way that you add it as a dependency is to come in here and edit your depend tags. Okay. If you want to edit it, I will show you. Technically, you can use the edit command here, so you could edit the package.xml file. And I didn't like that. So I personally like to use, you can use Vim. There are a lot of editors that are useful. I like using Sublime Text, which I installed over here. I just went to the Ubuntu software store, looked for Sublime Text, installed it in a nice GUI way. But it gives you this command subl, okay, for Sublime Text, and then a text file name, so package.xml, and it will open it up in Sublime Text, which opened up very small. But this is just your standard sort of text editor, but it has nice syntax highlighting for most of the types of files that you'll encounter. So I really like this text editor. You can use any other editor. There are some that are built in. You can use Nano. There are a bunch that are built into Ubuntu. And U2 might have some built into them. Who knows? They're an enduring band, so you never can tell. So you can go in through here and you can edit hi.todo, save it, and that will have changed this package.xml file. So that's how you do editing here. If we did cat again on it, we would see that the change that I made and saved, of course, I have to save it, is included here, maintainer Piconi at hi.todo. So that was the little edit that I made. Great. Now that we have a package, we can add Python code files, .py files, that will become ROS graph nodes to the suite package/source directory. So this is where we're going to actually work on our packages. Before we do this for our own package, however, let's first learn how to run some nodes that come from pre-existing packages. And that's what we'll do in the next lecture, 6.3.